Welcome back to another video on Isaac Physics study session with me. Today we're going to tackle a very difficult question on Isaac Physics with difficulty index 2Cs. As you can see here, that is a very difficult question, and this video might take as long as 30 minutes, we don't know, or it might be as short as 5 minutes, so let's get tuned in. You're welcome to attempt this problem as I go along. I haven't seen this problem before, so I'm going to go through the most basic steps to solve this problem correctly. So let's get into it. The question states the apparent magnitude m of an astronomical object describes on a logarithmic scale how bright an object appears to an observer. It is related to its actual brightness or energy flux F, i.e., the energy arriving at the Earth per unit area per second, in the following way. Consider two objects with magnitudes m1 and m2, and brightness f1 and f2, and the relationship is quantified as the following. So let's actually think about the difference between brightness and magnitude. So it says the apparent magnitude m is described on a logarithmic scale, like such. This is a logarithmic scale. And most importantly, it says it's about how bright an object appears to an observer. So it's the apparent one. But the actual brightness is related to the actual brightness or energy flux. And energy flux is the energy per unit area per second that's arrived at the Earth. So we're given this formula. So part A, it's the sun and moon. So it says the magnitude of the sun is minus 26.8, and it is a factor of 4.8 times 10 to the power 5 brighter than the full moon, by the magnitude of the full moon. So we're going to say, well, let m1 be the magnitude of the sun, m2 equals the magnitude of full moon. So f1, we know that it is f1 is 4.8 times 10 to the power 5 brighter than the moon. So we have 4.8 times 10 to the power 5 is equal to 100 to the power of m2, which is x, minus m1, which is plus 26.8 over 5. And, well, we can take both sides, the log of 100. And so taking the left-hand side of log of 100, we would get, let me think. So taking the left-hand side, log base 100 is equivalent to taking the natural log of the left-hand side divided by the natural log of 100. Okay, so essentially you can say what natural log of 4.8 times 10 to the power 5 divided by the natural log of 100 is equal to x plus 26.8 divided by 5. So times that by 5 and minus 26.8. So you get the magnitude m2, the magnitude to be approximately minus 12.6. And let's just verify the answer on the website. I think it should be the answer, but let's just check. Value minus 12.6. Is that right? Yes, it is correct. So let's move on to second question, part B. It says the supernova was discovered in the nearby dwarf galaxy, the Large Magellanic cloud and with a magnitude of plus 2.9. It was visible with the naked eye. It was subsequently discovered that its progenitor was a blue. What does a progenitor mean, actually? This channel is all about learning, so if we encounter something we don't know, let's search it up, because we want to know everything. Not know everything, but if we encounter something we don't know, let's make it known, right? So Google progenitor. Progenitor means a person or thing from which a person, animal, or plant is descended. An ancestor. Okay, so progenitor means ancestor in this case. Ancestor. So it was subsequently discovered that the ancestor was a blue supergiant. So it's going to be very hot with a magnitude of plus 12.2. Find the ratio of the brightness of supernova to that of its progenitor. So the ratio of brightness, F1, oh, why am I yellow here? So F1 divided by F2 is equal to 100 to the power of M2 minus M1 divided by 5. So we want to find what F1 over F2 is. So this is the brightness of supernova, and F2 is the brightness of the progenitor. And that's equal to 100 to the power of M2, which is the, the magnitude of the progenitor, which is 12.2, by the way, minus M1, which is 2.9. So this answer to two significant figures is 100 to the power of 12.2 minus 2.9. That's about 3.98 times 10 to the power of, or two significant figures, so 4.0 times 10 to the power of 18. Let's check the answer. So it says two significant figures, so 4.0 times 10 to the power of 18. It says my question attempt failed due to internet issues. Let's refresh things again. So 4.0 times 10 to the power of 18. And it says it's incorrect. Well, what is... Okay, so it is incorrect. Not 4.0 times 10 to the power of 18. Well, what's the issue here? Don't see any issue. Let's read the question again. So the question has, find the ratio of brightness of supernova to the progenitor. So F is the brightness, and M2 here is the magnitude of the progenitor, 12.2, and M1, oh, you need to divide by 5, okay. That's why I got it wrong, because it's 100 to the power of, the 12.2 minus 2.9 is equal to 9.3, right? Yeah, 9.3. So it's 9.3 divided by 5. So you'd get, actually, this would be 5,200 times brighter. So the supernova would be 5,200 times brighter than progenitor star, 5,200, and it's correct. So always be careful with answering the questions.